Good day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's topic, do not forget to like, share, subscribe, and click on the notification button. For partnership, this is my line number 081413645573. That's my phone number. This is my phone number, and this is my OPay account. 81413645573. We will appreciate your sponsorship so that this video can reach as much targeted audience as possible. So this is my OPay account for partnership. Today we are taking a topic under calculus, and that topic is integration. Integration means antiderivative. So we want to derive the expression for the volume of revolution generated by the curve of a function. Thank you. Now let's consider this arbitrary curve of y is equal to f of x. For this is a dependent variable against this independent variable x. Now look at this curve that I have here. Let's say I take arbitrary point P1, I take another arbitrary point P2, and this P1 on the x-axis is x. So my P2 that I'm going to have here is going to be x plus delta x, and then the distance between them is just delta x here. Now if I revolve this graph, I turn it 360 degree round, I'm going to have what is called, I turn it 360 degree along the x-axis. So this x-axis will be centralized within the volume generated by this curve. So this curve now, I'm trying to move it 360 degree about x-axis. If I move it 360 degree about x-axis, I'm going to have this particular shape that has the volume called volume of revolution. If you look at this place, the curve will turn this way, and I will have something like this. Now this is the solid of a revolution. We want to find its volume. Now if you look from here to here, if I take it as my y, and from here to here will be y plus delta y. Now if you look at this particular shape, this shape look like more or less like a cylinder. I think you can see now a cylinder. Now we know very well to find the volume of this cylinder, volume is usually base area times height, and the area of this cylinder, the area, the volume generally in mathematics is base area times height, and the base of this cylinder is circular, and the area of a circle is pi r squared. The radius of this circle squared. So I can have something like this, pi r squared times height. The height of your cylinder is this, so times h. So the same way with this volume of revolution. Now because this quantity delta x is very small, the volume of this shape is just delta v. So using this analogy I have here, I have delta v. The circular part of this shape is this, that's the base. You can see that this particular base, the circle is this, therefore the radius will be y. So I will have pi, using this, radius will be y for this shape from here to here is the radius r. So pi y square, then the h is the height of this solid, and the height of this solid from here to here is delta x. So I'll put delta x here. Now limits of this volume as delta x tends to 0 is equal to dv. We say it as limits of pi y square delta x as delta x tends to 0, and this yield pi y square dx. So this v I have here now is equal to pi y square dx. So let me rewrite this here. I have the v is equal to pi y square dx. So to find the total volume of this solid of revolution, we integrate both sides. That means integrating the infinitesimal volume, tiny volumes. Then we integrate this other side. And integration constant, we can take it outside the integration side. So integration of the v is v. So it will be equal to pi is a constant. You take it outside the integration side. So integral y square dx. So this is the formula for the volume of revolution. Now, let's say function y that I have here is let's say it's a 3l squared. So if you are asked to calculate, okay, let me give an exercise. Example. The question say find the volume of revolution of the curve y is equal to 3l squared about the x axis in the limits 1, 4 on the x axis. In my last video, I talked about the area under this particular curve. So this time around, I'm revolving that curve about the x axis to generate this volume of revolution. So in a nutshell, if you want to determine the volume being generated when you turn this curve about the x axis, I've derived the formula as solution. V is equal to pi integral y square dx, and the limit given in the question is from 1 to 4 on the x axis. So I'll write 1 to 4, and the value of the function y is given as 3l squared. So I'll write this as pi integral 1 to 4, then 3l squared raised to power 2 in the formula dx. Now I can simplify this as pi integral 1 to 4 3l squared. According to law of indices, 3 squared will give us 9. L squared means, according to law of indices, use this power to multiply. That is x raised to power 4. So that is 9x raised to power 4 dx. In my other video, I have already discussed how to determine integration of a given function. So we had one here, whatever we get, we divide by this. So I will write this constant, then I put this limit out there, 1 to 4. So I will write this 9. Then this x raised to power 4 will be x raised to power 4 plus 1 all over 4 plus 1. So this can be simplified as pi 9 x raised to power 4 plus 1 is 5 all over 5. Then in the limit 1 to 4. So 1 to 4. So what I have here now is going to be pi. Then we substitute this 4 here. That is 4 raised to power 4 raised to power 5. You now see minus. You substitute 1 here. 9 times 1 raised to power 5 divided by 5. This 4 too is also divided by 5 that I have here. So this can be simplified as pi. So I will take my calculator and get what is 4 raised to power 5, 4 over 5 raised to power 5. This is 4 divided by 5 raised to power 5. So I have, what I have here is 0.32768 in decimal form. Take away, so 9 divided by 5 is equal to sorry, times 9. I have 9 here, so times 9. This is supposed to be 9 times 4 raised to power 5 over 5. 9 times 4 raised to power 5 over 5. So I have 2.94912. Take away, then 1 raised to power 5 is 1. 1 times 9 is 9 over 5. So 9 divided by 5 as its decimal is 1.8. So what I'm going to have now, the volume of revolution now will be pi times, we have its subtraction. So I'm having times 1.14912, which can also be written as 1.14912 times pi. You can leave our answer in terms of pi. So the unit will be unit cube. Volume is in cube. The unit of volume is in cube. Unit cubed. So that is the simple introduction on how to determine volume of a revolution in calculus. Now, there are some aspects in which the graph can be revolved about the y-axis. In this case, the formula for revolution about the y-axis will be pi integral s square dy. About the x-axis will be pi integral y square dx. So take note of this. This one is about the y-axis, and this formula for volume of revolution is about the x-axis. Take note of that. Thank you for your time. I believe that you are able, to have the idea of the application of integration in finding the volume of revolution generated by arbitrary curve. Have a nice day. Bye.